أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Projection of lines inclined to one or both of the principal planes of projection, that is the horizontal plane and the vertical plane. There are some hints to be remembered while projecting lines inclined to one or both of the planes. That consist of the true length and true inclination. True inclination with the horizontal plane theta can only be seen in the front view. You can see here that the line AB, which is in this instant inclined to only a horizontal plane. You can see the ends distances of the line AB from the horizontal plane. And A has this much distance above the horizontal plane, and B is at some greater distance as compared to and A from the horizontal plane or above the horizontal plane. So as the two ends are not equidistant from the horizontal plane, so the line is said to be inclined to the horizontal. Now, as the line is inclined to the horizontal plane, its inclination theta can only be seen in the front view while looking into the line in the front view from this direction or from this direction. This can exactly be judged or seen. While if you look at this line from the top view, so the theta will be hidden behind this line, so you cannot judge the theta or the inclination with the horizontal plane in the top view. You can only see it in the front view. The length of the top view is dependent on theta. Top view and theta are inversely proportional. You can see that the top view of this line AB has been shown here, as the top view will always be formed at the or on the horizontal plane and would be shown with a smaller case later without a prime on it. So you can see that by looking into this line from the top, its two end would be projected to this position and A and B would be projected to this position. And when you join these 2 points, so you will get its top view. Now, as you can see that the top view AB shown in blue is shorter than the true length or the actual length of the line. So it depends on theta. The greater the theta, the smaller would be the top view. Or if you decrease the theta to 0, then it would mean that you have made line AB parallel to the horizontal plane as well. So in that case, the true length will be shown in the top. Now you can also see that In this case, the line is parallel to the vertical plane. You can judge it from its two ends distances from the vertical plane, and A has this much distance, and similarly, and B has the same distance from the vertical plane. So the line is parallel to the vertical plane. You can also see the true length on the vertical plane or the true length in the front view. The position, so the length of the top view is dependent on theta. Top view and theta are inversely proportional. You can see increasing the theta or by moving this end further away from the horizontal plane. You can see if you can move it to this position, you can see that then the top view will be decreased to this much. Further increasing the theta will further reduce the length of the top view. So theta and top view are inversely proportional. Or if you decrease the theta by moving this end and B towards the horizontal plane, or reducing the distance of end B relative to end A from the horizontal plane. You can see to this position now. Now the line would be this, and its top view will be this much from here to here. So you can see that decreasing the theta increases the length of the top view, or eventually, if you decrease the theta to zero, means that making the line parallel to the horizontal plane, then the top view would be exactly of the true length or equal to the length of the line. So the position of the top view is a function of the true inclination with the vertical plane, that is pi. Now, the position of the top view. In this instant, the top view, which is AB, is actually parallel to the XY reference line. You can see that the distances of the ends in the top view from the XY reference line are the same, means that the top view is parallel to the XY reference line. In this case, the line is parallel to the vertical plane, means that the inclination with the vertical plane is zero, or in this case, pi has zero value. So when pi is zero, or if the line is not inclined to the vertical plane, so its top view will be parallel to the XY reference line. So the position of the top view is dependent on pi. We will see that if we make the line inclined to the vertical plane, then what would happen to the top view? If the front view of the line is true length, then it must appear at an angle theta with the XY reference line. You can see that as the front view, in this case, is true length are equal to the length of the line itself. So that must appear with an angle theta with the XY reference line. The very moment one sees a shorter length in the front view, the apparent angle shall be larger than theta. Now, for example, if we move and B to this position in order to increase its distance relative to and A with respect to the vertical plane, so we would make it inclined to the vertical plane as well. As you have moved and B to this position, to B1 position, now you can see the ends distances from the vertical plane. And A has a similar distance in front of the vertical plane, but and B is now at some larger distance as compared to the end A from the vertical plane. So means that you have made line AB inclined to the vertical plane as well. Now, if you have done that, what happened to the theta or what happened to the true length of the line in the front view? So, by drawing a new front view, you can see that and B has been rotated to this position and is given the name B1. Now, projecting the and B1 onto the vertical plane with a perpendicular projector perpendicular to the plane of projection and and similarly and A would again be projected to the same position because we haven't moved and A and B1 will be projected to this position on the vertical plane, and when you again join these two end points, so you will get the front view. Now the new front view, as you can see, is shorter than the true length because you have made the line AB inclined to the vertical plane as well. And look at the angle theta that it was making with the XY reference line while it was of true length. Now, as the line has been made inclined to the vertical plane as well, so the apparent angle, because you haven't changed the inclination of the line with the horizontal plane, that remains the same, but you have made it inclined to the vertical plane as well. So the effect of that is that the front view would now appear shorter than the true length, and also the inclination of the front view will be greater than the angle theta, and this angle, this apparent angle, will be called alpha. It is called apparent angle because you haven't changed the inclination of the line with the horizontal plane. As the inclination of the front view is dependent on the inclination with the horizontal plane, so you haven't changed that, but you only have changed the inclination with the vertical plane, and its effect on the front view is that the front view would become shorter than the true length, and the apparent angle alpha would be greater than the angle theta. Now, what would happen to the top view? Previously, as the line was not inclined to the vertical plane and it was only inclined to the horizontal plane, so the top view was parallel to the XY reference line. Now, as you have also made the line inclined to the vertical plane, so its effect on the top view is that the top view will not remain parallel to the XY reference line and it would move to this new position because drawing the top view of the new position and B one would be projected to this position and A would be projected to the similar position because you haven't changed the and A. So by joining these two endpoints, so you will get AB1. Now this AB1, although of the similar length as was AB, but is now inclined to the XY reference line. So if the top view of the line is true length, then it must appear at an angle phi with the XY reference line. If the front view of the line is true length, then it must appear at an angle theta with the XY line. The very moment one sees the shorter length in the front view, as is this case, now the front view is shorter than the true length, so it must appear at an angle alpha greater than, it must appear at an angle greater, apparent angle larger than theta, and that apparent angle will be called alpha. True inclination with the vertical plane, phi can only be seen in the front. Now, in the first instant, the line is only inclined to the vertical plane. You can see the ends distances, and A has this much distance in front of the vertical plane, and B has this much distance in front of the vertical plane. So as the two distances are not equal, so the line is inclined to the vertical plane. And look at its position with respect to the horizontal plane. And A has this much distance from the horizontal plane or above the horizontal plane, and B has similar distance above the horizontal plane. So in the first instant, the line is only inclined to the vertical plane. Now the inclination with the vertical plane, that is phi, can only be seen in the top view. By looking at the line from the top, you can only judge or see the angle pi. You cannot see it by looking into the line from this direction or in the front, because in that case, the angle would be hiding behind the AB line, or you cannot exactly depict its size. You can only see it by looking at this plane perpendicularly or in the top. So, as the line is inclined to the vertical plane, so the projection on the vertical plane, that is the front view, will be shorter than the true length. Looking at from this direction or drawing its front view, and A would be projected to this position, and B would be projected to this position. And when you join these two endpoints, so you will get a line as its front view, and you will annotate it with A prime and B prime. For the top view, looking at it from the top, and A would be projected to this position, and B would be projected to this position. These two projectors must remain parallel to each other and must also remain perpendicular to the plane of projection. In the top view, the plane of projection would be the horizontal plane. In the front view, the plane of projection would be the vertical plane. So you will get the top view, the projection of the two ends, and when you join it with the line segments, you will get the top. Now you can see that the top view in this case is of true length as the line is parallel to the horizontal. So on the horizontal plane, it would show the true length, or in the top view, it would show the true length. While in the front view, you can see the shorter length of its front view. So the length of the front view is dependent on the pi or the inclination with the vertical plane. If you increase the pi by moving this end further away from the vertical plane, so this would get shorter and shorter. And by moving this end towards the end A or towards the vertical plane by decreasing the angle pi, so you would increase the length of the front view, and eventually when you decrease the pi to zero or to make the line parallel to the vertical plane, the front view will be exactly equal to the length of the line. So the length of front view is dependent on pi. Front view and pi are inversely proportional. As I have told you, by increasing pi, you will decrease the front view. And by decreasing the pi, the front view will increase, or the length of the front view will increase. So they are inversely proportional to each other. If the top view is of the line is true length, then it must appear at an angle pi with the xy line. If the top view is the true length, in this case, the top view is the true length because the line is parallel to the horizontal plane. So this top view must appear with an angle pi with x. The very moment one sees a shorter length in the top view, the apparent angle shall be larger than pi. Now, you can only see the shorter length in the top view if the line becomes also inclined to the horizontal plane. Now, you can make it inclined to the horizontal plane as well by moving this end B away from the horizontal plane as compared to end A. By increasing the height of end B above the horizontal plane as compared to end A. So if you move the end B to end to B1 position, now look at the end distances now from the horizontal plane. And A has the similar distance because you haven't moved end A above the horizontal plane. But look at the end B. And B is now at some greater distance above the horizontal plane as compared to end A. So you have made this line inclined to the horizontal plane as well. Now look at the top view. The top view of end A will come exactly at the same position because you haven't moved it. But look at the top view of end B1. So it would be drawn at this position, and when you join these 2 points, so you will get the new top view, which is AB1. Now AB1, as you can see, is shorter than the true length of the line. ABR, AB1. So initially, when the top view was the true length, so it was appearing with an angle pi. And look at the front view. The front view would was parallel to the XY reference line when the line was only inclined to the vertical plane and was parallel to the horizontal plane. Now, if you have made the line inclined to the horizontal plane as well, now what happened to the top view? The top view has decreased in length, and also the angle that the top view is making with the XY reference line has also increased from pi to beta, which is called the apparent angle. Now, what happened to the front view? The front view was initially parallel to the XY reference line, but once you have moved this B and to B1 has made the line inclined to the horizontal plane as well. Now, what happened to the top view? Sorry, the front view. The front view has also gone to this position, remain of similar length, but the angle that the front view is now making is greater than the angle that it was previously making. The previously, the front view was parallel to the XY reference line. Now the front view is at some greater this angle as compared to angle 0. Initially it was parallel, so means that theta was 0. Now this new position is at some greater angle as compared to 0 with XY reference line. So this has also increased. The apparent angle of the line with the vertical plane is beta. So that beta will be greater than the angle phi. And also the position of the front view depend on the angle theta with the horizontal plane. Requirement to draw the projection of a line AB inclined to. So you have seen here that the dependence of the front view is with respect to the angle pi. If you increase the inclination with the vertical plane, then the front view would get shorter and shorter. And also the position of the front view is dependent on theta. Its size depend on pi and its position depend on theta. Initially, when theta is 0 or if the line is parallel to the horizontal plane, so the front view is also parallel to the XY reference line. And when you make the line inclined to the horizontal plane as well, so position of the front view also changes and it doesn't remain parallel, and it also is appearing at some greater angle com- as compared to theta. And its top view is dependent, the position of the top view and the inclination of the top view is dependent on the angle theta. When the theta was 0, so the top view was appearing at an angle pi, and the top view was in that case also of true length. But when you increase the theta from 0 to some angle, then the apparent and then the top view also gets shorter and also appear at an angle greater than pi, and this apparent angle is called beta. It is called apparent angle because you haven't changed the angle with respect to the vertical plane. That remains the same. That was which was initially with the vertical plane, but only you have changed the inclination with the horizontal plane, and the effect of that is that the apparent angle in the top view appears to be greater than pi, and that apparent angle will be called beta. Requirement to draw the projections of a line AB inclined to both planes. So the front view distance of the front view of end A from the XY reference line, distance of front view of end B from the XY reference, length of the front view, angle of the front view with the XY reference line, that is alpha, distance of the top view of end A from the XY reference line for the top view, distance of top view of end B from the XY reference line, length of the top view and angle of the top view with the XY reference line, that is beta. Now these are the requirements. So you must have and A distance from the XY reference line and B distance from the XY reference line are the apparent angle alpha, or you can also have and A distance from the XY reference line in the top view and B distance from the XY reference line in the top view and apparent angle beta. So let's see how to draw a line inclined to both planes. A line AB 80 mm long has its end A 30 millimeter above the horizontal plane and 20 millimeter in front of the vertical. So a line is 80 millimeter long. It has two ends and A, and the position of end A is given relative to the horizontal plane, and the vertical plane it is 30 millimeter above the horizontal plane and 20 millimeter in front of the vertical plane. So just treat the two ends as a separate points. So you have gotten the location of ends A above the horizontal plane and in front of the vertical plane. The line is inclined at 30 to the horizontal plane and 45 to the vertical plane. Draw its projection. So these are the hints. The given data, the line AB is of 80 millimeter length and A is 30 millimeter above the HP and 20 millimeter in front of the VP. So these are the hints upon which we would rely to draw the projection of this line. Now, first of all, you will have to draw the XY reference line. And now to locate the end A, as it is 30 millimeter above the HP, so its front view would be 30 millimeter above the XY reference line. And as it is 20 millimeter in front of the vertical plane, so its top view will be 20 millimeter below the XY reference line. So we know that its front view will be coming 30 millimeter above the XY reference line, and its top view will be coming 20 millimeter below the XY reference line. Now for that you have drawn locus are lines parallel to the XY reference line, So on this line, and A may be placed anywhere on this line, and the front view of end A. And the top view of end A would also be in alignment to the front view, but would come on this locus line. So from here you have started, you have drawn end A front view, and exactly in alignment to the front view, its top view would be drawn, and that would come 20 millimeter below the XRF. Now, the other hand that is given is that the line is inclined 30 degree to the horizontal plane. So, it must be made 30 degree with the XY reference line. So, you have already drawn a locus line parallel to the XY reference line. So, you can measure this angle from this line as well, as this locus line is already parallel to the XY reference line. Now, also you are given the true length of the line, which is 80 mm. So, you have gotten the ends A front view. So, its end B will be the other end of the line. But you are also given this hint that the line is inclined at 30 degree to the horizontal plane. So make it 30 degree with the XY reference line and draw a line of 80 mm that would end at this position. So this end would be called its end B, and its front view would be denoted with B dash. Now already the top view of end A has already been drawn. The top view of end B will be drawn through a perpendicular projector. This projector must remain perpendicular to the XY reference line, and as the line is in the first instant, we have assumed it to be inclined to the horizontal plane only and is parallel to the vertical plane. So in that case, the top view will also be parallel to the XY reference line. So the other end of and B would come at the locus of and A. Now you have drawn the first step. Also draw locus for and B. Now, in the next step, we would assume the line to be inclined to the vertical plane only and parallel to the horizontal plane. So for that, already the position of ends A is given. That is, the front view would come 30 millimeter above the XY reference line, as and A is 30 millimeter above the horizontal plane. And also, this and A is 20 millimeter in front of the vertical plane, so its top view will be 20 millimeter below the XY reference line. So this is again a repetition of the ends A. Now, in the next step, we will this step we will assume the line to be parallel to the horizontal plane and inclined to the vertical plane only. So for that, we will draw a line starting from the top view of end A and making an angle of 45 degree with the XY reference line, as this locus line is parallel to the XY reference line, so you can use this as a reference as well. So with the protector, measure this angle of 45 degree and start from here and draw a line of 80 mm. So that would end at this position. So name it as and B. So as in this step, you have given it the annotation A1, B1. So this end would be called the B1. Already the front view of this end has already been drawn. So for the front view of end B, draw a perpendicular projector. As in this case, we have assumed it only to be inclined to the vertical plane and parallel to the horizontal plane. So in this case, the front view would be parallel to the XY reference line, and the end B front view would come at this position. Also draw locus for end B as well. Now you have done these two steps separately. Now you can conclude or move towards the final step. Now in this final step, again locate the same positioning of the end A. That is the front view of end A again would come at the similar position and also the top view. This time annotated with A2 prime and A2. Now take this distance of the front view with the help of the compass, measure it and place this line with the help of the compass. Start this as a center and radius equal to A1 dash, B1 dash. Open the compass and draw a line. Draw a line. That line would intercept the locus of and B at this position. So join the intersection point with and A. So you got the front. Now this top view. Open the compass from A to B and this be the center. Draw a line. So that line would intercept the locus of and B and join it with A2. So you got this type. Now join the two ends with a perpendicular projector. So you are done with, you have drawn the projection of a line inclined to both the plane or the front view and top view of a line inclined to both the plane. You can see that finally the inclination of the front view would appear greater than theta and that apparent angle would be called alpha. And also the inclination of the top view will also be greater than the angle phi that the line is making with the vertical plane and it would be called apparent angle beta. So you can measure. Finally, the front view would be shorter than the true length as well as the top view will also be shorter than the true length because the line is inclined to both the planes. These were the assumption steps in order to get this final projection. Because in the first step, we had assumed the line to be inclined to the horizontal plane only and parallel to the vertical plane. In the second step, we had assumed the line to be inclined to the vertical plane only and parallel to the horizontal. But the line was actually inclined to both the planes. So this is the final projection that was required. Now you can combine all these three steps in a single, uh, for example, if you want to spare the drying area because this would require uh, greater drying area or the space requirement for this method is a little bit more as compared to this one. The result would be the same. The first step would be similar. The first step would be similar that in the first step you will assume the line to be inclined to one of the plane only, that is the horizontal plane, and parallel to the vertical plane. This was the first step. Now you have assumed the line to be inclined to the horizontal plane only, and for that you have drawn its front view as was the first step in the previous. Now for the second step, start from end A and assuming the line to be inclined to the vertical plane at 45 degree. So draw a line making an angle of 45 degree of 80 mm starting from end A, and this line would end at this position. Name it as end B or B1 and also draw a locus line parallel to the XY reference. Now already the front view of this end has already been drawn, and for drawing the front view of this end B, draw a perpendicular line or perpendicular projector perpendicular to the XY reference line, and that would end at the locus of A dash or parallel to the XY reference. Now, the next step would be to make these front views and the top views which are parallel to the XY reference line made or make them inclined to be to the XY reference line by rotating them clockwise and anti-clockwise. For example, for the front view A dash B1 dash, open the compass from A dash to B1 dash and A dash be the center. A dash be the center. Draw an arc or rotate this and B1 dash till it cut the locus of B dash. So join the intersection point with the end A dash. So this is the final front view, and this is the apparent angle alpha, which is greater than the angle theta. Similarly, for this top view, which is parallel to the XY reference line, now open the compass from A to B and A as a center, rotate this and B clockwise so that it cuts the locus of B1 at B2 position and join it with and A. So this is the final top view, and this is the apparent angle beta greater than the angle phi. So you can do it like this as well. Line AB has its end A 30 millimeter above the HP and 20 millimeter in front of the V. Now, this was the case when we were given the actual length of the line and the inclination theta and pi with the horizontal plane and with the vertical plane respectively. And we were asked to draw the final projections are the front view and the top view. In some cases, we will be given the front view and the top view for a line, and we will be asked to find the true length and the true inclination, that is theta and pi. We will be given the front view, the length of the front view along the apparent angle alpha, and the length of the top view along the apparent angle beta, and we will be asked to find the true length along the true inclination pi and the true length in the front view along the true inclination theta. So we can do that as well. A line AB has its end A 30 millimeter above the HP and 20 millimeter in front of the VP. So again, the hint for end A is given. So the front view of this end would be 30 millimeter above the XY reference line and 20 millimeter below the XY reference line. The front view would be 30 millimeter above the HP, above the XY reference line, and the top view would be 20 millimeter below the XY reference. The front view of the line is 65 millimeter long. Now the front view is given, not the actual length of the line, and is inclined at 60 degrees. So the front view would appear with an angle alpha at 60 degree to the XY line, whereas its top view is inclined at 45 to the XY line. Draw the projection of the line AB and its true length. Also find its true inclination with the horizontal plane and the vertical. So we are required to find the true length of the line and the true inclination theta and pi with the horizontal plane and the vertical plane respectively. So the first step would be similar, that we are given the hint for the ends A, that end A is 30 millimeter above the horizontal plane, so its front view would be 30 millimeter above the XY reference. Similarly, and A is 20 millimeter in front of the vertical plane, so its top view would be 20 millimeter below the XY reference line. So you have drawn the locus line for these two ends, uh, this ends A, front view and top view. Now we are given the length of the front view, which is 60 mm, and also we are given the apparent angle alpha. So draw a line making an angle of 60 degree. Start from A dash, and this line would end at this position. Name it as B dash. Draw the locus for B dash as well. Now for the top view, draw a perpendicular projector of ends B. We are given the inclination of the top view, which is 45 degree. We are not given the length of the top view, but starting from end A, making an angle of 45 degree, draw a line. So that line would intersect the perpendicular bisector of end B at this position. Now join it with end A. So this is the length of the top view. This was given, the angle was given, but the length was not given. We have gotten the length through this step. Now the next step would be to make them parallel to the XY reference line. Also draw locus for this. Now, in order to get the true length of a line, you must make it parallel in one of the view. If you made the top view parallel to the XY reference line, then the front view would give us the true length. Rule in the front view parallel to the XY reference line, then the top view would give the true length. Now, for the first step, you have made this top view parallel to the XY reference line. How? Open the compass from A to B. Now, this A as a center, rotate this and B anti-clockwise so as to make it parallel to the XY reference line. So, it would end at the locus of A, which is parallel to the XY reference. So so the new position of B would be B1. Now this A B1 is now parallel to the XY reference line in the top view. So if we draw the projection from this top view, which is parallel now to the XY reference line, then the front view would give us the true length. As the front view of this and A has already been drawn, A dash, for the front view of this and B1, draw a perpendicular projector perpendicular to the XY reference line and where it cuts the locus of B dash here, join this B dash with A dash. So this will be the true length of the line. And the true length must also appear with the true inclination with the horizontal plane. If one sees a true length in the front view, it must also appear with the true inclination theta. So measure this angle theta with the help of the protractor and measure this true length of the line with the help of the ruler. Now we have gotten the true length of the line in the front view and also we have gotten the true length, the true inclination of the line with the horizontal plane, that is theta. Now in order to get the true inclination with the vertical plane, that is phi. Now rotate this front. Open the compass from A dash to B dash and this A dash be the center. Rotate this B dash and clockwise in order to make it parallel to the XY reference line. So when you rotate it to this position, to the locus of A dash, which is parallel to the XY reference line, so you have made this front view parallel to the X direction. Now project the top view from the front view. As one of its end, the top view of end A was already been drawn. Now the top view of end B2 dash will be gotten through a perpendicular projector. Draw a perpendicular projector where it cuts the locus of B at this position. Join B2 with A. So you also gotten the true length because if one view is parallel, then the other must show the true length. Now in this case, we have made the front view parallel. Now the top view must show the true length. And if the top view is of true length, it must also appear at an angle phi, which is the true inclination with the vertical plane. As we had already gotten the true length in the front view, so the true length in the top view was not necessary because the length of the line will be 1. Either you get it in the front view or in the top view, but this step was necessary for getting the angle pi. It must also appear with the true length of the line. So this true length in the top view was necessary in order to get the true length of the angle pi. So that's end for today's lecture. I hope you have understood this. We can have interactive class if anybody has any problem. That's all for today. Thank you.